Class, this is a three-part video. We've been trying to get it to work today, and it's having extreme difficulties. But what we're looking at is the expression called a difference quotient. And basically, what they're asking you to do is to apply your composition of functions to be able to substitute in this extended f of x, which is x plus h, and subtract that expanded function, actually subtract this one, expanded function, regular function from the expanded. Now that I've spit that out, let's try it. It's easier than you think, than it looks. But basically, here is our function. Wherever we see f of x, we can put in 5x minus 2. So when I use this formula, that's what I'm using for my template. So now I have f of x plus h. Well, f of x is 5 times x. Well, I can't use just x. This has to be the expanded. So it becomes x plus h. And then, for that part of the function, it's minus 2. I am going to group this just so that you can see I have completed that part of my substitution process. Now, I want to subtract just the regular plain f of x. And I will put that in right here, 5x minus 2. Now, the reason why I put it inside brackets or parentheses, it doesn't matter, is that I want to be sure and distribute that subtraction sign out in front. And then all of that, of course, is over h. Now, we have done the very first step. The first step is to substitute. The second step is to distribute. And when I do that, we're going to end up with 5x plus 5h. Make that a better plus sign. And then minus 2. Going to the second part, that becomes negative 5x, and then plus 2, because I subtracted a negative. And again, that is over h. Now the cool part is, once I've done that, step 3 is going to be simplify. So I'm going to simplify the terms that I have. I have opposite pairs. A positive 5x will cancel with a negative 5x. A negative 2 will cancel with a positive 2. So when I look at what's left, I have this. I have 5h over h. And, of course, my h's, h divided by h is 1. So my final answer or evaluation will be 5. When you do this process correctly, it's really cool because most of your terms will cancel. Okay, let's try this second one down here, and you'll notice this time my f of x is not just 2 terms, it's 3. And I also have the square. So let's try this one. So again, I'm going to start off with the very first part, and I'm going to plug in x plus h wherever I have x. So here we go. That is going to be x plus h, quantity squared, minus 3 times x plus h. That blue is really light. And then plus 8. Then I'm going to subtract the original function. And that becomes x squared minus 3x plus 8, all over h. And that is such a horrible color on here. I think I'm going to go back to my purple. Okay, now then I've done my substitution. I need to do my distribution. Well, this is the square. You can either FOIL or you can use our shortcut we've been working on. And that becomes x squared plus 2xh plus h squared, and that's this piece right here. Now then, minus 3x minus 3h, and then plus 8. And now we'll work on this piece. Simplifying it, minus x squared plus 3x minus 8 all over h. Now we'll go back and use our opposite pairs. An x squared and a negative x squared will cancel. I have a positive 8 and a negative 8. Our opposite pairs, opposite operations, reduce to 0. A negative 3x and a positive 3x. And it looks good, but we have a few things extra that we didn't have last time, but don't panic. We're looking at 2xh plus h squared minus 3h's over h. And it just looks like we have h's everywhere. But remember that we can GCF this stuff. I'm going to put this over here. See if we can get it in. I'm going to factor out an h. Greatest common factor is h. So that's going to leave me at 2x plus an h minus 3. And that's all divided by an h. So when I look at it, this is going to cancel. That cancels, and this cancels. Or over here, h divided by h. That leaves us with a solution of 2x plus h minus 3. Order really doesn't matter on that. You just have to get all three terms. And that is the first part. Before I close this out, you will be required to do number 11. Everyone must be able to do a plug and chug on a linear equation. Something like number 12 will probably end up being a bonus on your test. So you might want to practice doing that one. Okay, that's where we'll stop on this page.